Hello again. This is our tutorial for our notes on solving equations algebraically, the first set of notes. Last week, week 6 on our distance learning, we did solving equations using the sketch method. So this week we're going to transition that to using algebraic methods on week 7. But the process is basically the same as far as last week. We found out that what we did to one side, we had to do to the other if we were like taking away um, triangles or x's or taking away the constants to cubes. And that same rule applies to algebra, the algebraic methods. One of the essential rules of math is that you have to do the same thing to both sides. You can do anything you want to an equation as long as you do it to both sides. And one of the other big things with math is when you're doing that, you want to be judicious and do things that actually help you solve the equation. So when solving algebraically, we use opposite operations. So if something is connected with addition, we use subtraction. If something is connected with multiplication, we use division. And we also saw that with the triangles because when they were already there, we took them away. So that was the opposite. So looking at the first two examples on this one, this is just the very first simple ones that we did before. Now when we did this one, these two types of examples, I'm looking at 2 and 3, the ones I highlighted. With sketching, we sort of did what we call the guess and check method. But after a while, that method becomes kind of cumbersome. So I'm going to use the algebra method. What I really want to do is I'm going to draw my line. I want to get that x by itself. So that means I need to get the 2 away from it. Okay, so if I want to get the 2 away from it, I need to look at how it's connected. That is 2 multiplied by x, or 2 times x, which we read as just 2x. But it's connected through multiplication, and the opposite of multiplication is division. So I'm going to divide by the 2 to remove it, and 2 divided by 2 is 1, so I end up with 1x. But I've got to remember my first rule over here that says I have to do the same thing to both sides. So if I divide the left side by 2, I've got to divide the right side by 2, and 12 divided by 2 is 6. So 1x equals 6, and you don't have to put the 1, that can just become part of your box. So x just equals 6. If I want to check it, I can come back over here sort of to the side, and I can say, okay, I've got 2x equals 12, and in the position where the x used to be, I'm going to take out the x and use parentheses. When I take out a letter, I use parentheses to indicate that. Everything else stays the same, but in the place of where the x used to be, I'm going to put a 6, and then once again, I'm just going to use basic math. This means 2 times 6. 2 times 6 is 12. I've got a 12 on the left side, and I've got a 12 on the right side. So just as before, I need to have the same number on both the left and the right. That balances. That means that my answer of x equals 6 is correct. I'm going to look at example 3. I'm just going to draw my line. And just like before, I want to get that x by itself. And just like before, that 3 is being multiplied by the x, so the opposite of multiplication is division. So I'm going to divide by the 3 again, and 3 divided by 3 makes a 1, so I get 1x. So now my x is by itself, but I have to do the same thing to both sides, so I have to divide the other side by a 3. And 15 divided by 3 is 5. And remember, we don't have to put a 1x because x is the same as 1x. So now that I know what 1x is, that can just become part of my box. And I can say x is equal to 5. Then if I want to check it, and I do, I come back over here and I say 3x equals 15. I'm going to take out the x. I'm going to use parentheses to show that I took it out. But in its place, I'm going to put in that 5. And then I'm going to multiply, because that's what that is, 3 multiplied by x. Now it's 3 multiplied by 5. And 3 times 5 is 15 on the left, and I get 15 on the right. So I have the same thing on both sides. It balances, so my answer of x equals 5 is correct. I'm going to go to slightly more complicated. I'm going to use the same basic ideas. I'm going to look at number 1, where I have variables on both sides. Notice I have x's on both sides now. I'm going to draw my line. I'm just going to remember our notes that we did basically at the beginning of the year. Okay, DCID is our sort of our acronym to help us remember. The D means distribute. So if you remember, that's when you do that multiplication if you've got parentheses. And in this case, we don't have any parentheses, so I really don't need to distribute this time. C means combine like terms, so I'm just going to put CLT. Now that's if you have variables, more than one set of variable on each side. And if I look at it, just over here on the left-hand side, all I've got is a 2x. There's nothing over here with it that I can combine. Over here on the right-hand side, I've just got an X with an 8, but I can't put them together because X letters, variables, can only be combined with the same variable, and the 8 doesn't have an X with it, so I can't put it together. So there's nothing that I can really combine here. I know I've got a 2x on one side and x on another, but combining means you're putting together stuff that's on the same side, not going across the equal sign. So there really is no combining step here, so I'm just going to X that out. Okay, the next thing on our DCID is I for isolate. And the isolate steps that we look at first are ones where you can add or subtract first. So that's what I'm going to look at first. And I notice that I've got x's on both sides, and I really want to get my x's together. That's a part of isolating. So I'm going to do this here. And I'm going to notice that there's no number in front of that x on the right-hand side, so I'm going to put a 1. Always go to my one with the fewer x's. So I've got 1x here. It would be good if I could get it to the other side with the 2x. And I am going to use opposites because that's one of my other math rules. So that 1x is positive and the opposite of that is negative or minus. So that's why we say we use the positive or negative first. So in order to move it, I'm going to minus the 1x. That'll make it cancel because 1x minus 1x is 0x is gone. But if I do it to the right side, I have to do it to the left side. So 2x minus 1x is just 1x. That's all I have left on that side. On the other side, I didn't do anything with this 8, so I'm just going to bring it down. That would be the same step when we used to sketch it as saying I'm going to take away the triangle from each side, and I have one triangle left and an 8 cube on the other side. Remember, one triangle is this x over here, and then the 8 cube is the 8. Now I just have one x left, and that's all I need because I want to know what x is. So now I have x is 8. If I want to go back and check it, and I do, I can come back over here to the side and write 2x equals x plus 8. And everywhere there's an x, I'm going to take it out to show that I've taken it out. And in its place, I'm going to put the 8. So I've got 2 times 8 is 16, and 8 plus 8 is also 16. It balances, same thing on both sides. So my answer of 8 is correct. And the last example I'm going to do here is example 4. It's the most complicated one. Once again, we're going to remember the DCID, distribute, but there's no parentheses, so I don't have to do that. The CLT, I don't have the same anything on each side that I can combine. I can't put the 2x and the 4 together because they don't both have letters or they're not both constants. And there's nothing on the 10 side to combine with it. So really the CLT step doesn't come into play yet. But the isolate step definitely comes into play. I need to get my x's by itself, and I notice my x's are by itself. I mean, my x is together. I don't have two sets of x's, but it's not by itself. I've got this 4 and this 2 with it, so I need to get those away. Remember, we always try to do the ones connected with a plus or minus first. I notice that the 4 is connected with a minus sign, so that's what I'm going to do first, is I'm going to move that 4 away. So in order to move the 4, I need to do the opposite. The opposite of minus is plus. And then think of it now as like a negative 4 and a positive 4. That cancels. But if I add 4 to one side, I have to add 4 to the other. And 10 plus 4 is 14. And on my other side, I'm just going to bring down that 2x because I didn't do anything with it. Now I need to get rid of that 2. That's my last step. It's another isolation step, so it is an isolate, but we just call it the divide step. If you have more than one x left over, you need to do this last step because you need to divide to get rid of that, because that's 2 multiplied by x, similar to those very simple ones we had up at the top. So in order to get rid of the 2, I'm going to divide by 2. 2 divided by 2 is 1, so I just have my 1x left, which is what I want. But then I've got to divide the other side by 2. And 14 divided by 2 is 7. So I end up with 1x, or just x, equals 7. Once again, if I want to check it, and I'm going to check it up here because I'm running a little bit out of room. So I've got 2x minus 4 equals 10. I'm just going to mark this out because I'm going to use this for my checking space. So I'm going to take out my x, and I'm going to put in my 7. Everything else stays the same. And then I'm going to follow my order of operations, which says multiply before you subtract. So 2 times 7 is 14. And then 14 minus 4 is 10. So I get 10 on the left, and I already had 10 on the right. So yes, it does balance. So x equals 7 is my answer.